Hello, PascoMath grade 7 teachers. Today we're going to look at 7.EE.2.4. We're going to read the standard, unpack it a little bit, look at what you could be doing in the classroom as well as what the students should be doing. So let's go ahead and get started. So the standard itself is rather lengthy. It reads, use variables that represent quantities in real world or mathematical problems and construct simple equations and inequalities to solve problems by reasoning about quantities. So part A is about the equation, two-step equations specifically. So they need to be able to solve word problems leading to equations of the form px plus q equals r and p times the quantity x plus q equals r, where p, q, and r are specific rational numbers. They need to be able to solve these equations fluently. And then also compare an algebraic solution to an arithmetic solution. So algebraic would be when they set up with a variable. Arithmetic would be where they can just figure it out through number sense. So the example there is perimeter of a rectangle is 54 centimeters, is length 6, what's the width? So they can model that with an equation, or they can just draw a picture and figure it out, just using some basic number sense as well. So that's the difference between an arithmetic solution and the algebraic solution. They also move into part B, solve word problems leading to inequalities. The form px plus q is greater than r, and px plus q is less than r, where p, q, and r are specific rational numbers. So again, they're very specific with the form, the type of, the structure of the inequality they need to be able to solve. They need to also graph that solution set and interpret it in the context of the problem. So the example they give in the standard is a salesperson, you're paid $50 a week, plus $3 a sale. This week you want to earn at least $100. Write an inequality for the number of sales you need to make and describe the solutions. And so look at the word solutions is plural, meaning there's more than one. So to unpack that a little bit. Students will become fluent in solving equations of the form px plus q equals r and p times the quantity x plus q equals r. They need to develop fluency in solving world problems. They wish they could do that too. Or word problems that can be modeled by linear equations in the form px plus q equals r and p times the quantity x plus q equals r. Students move from solving word problems with equations to word problems with inequalities of the form px plus q is greater than r and px plus q is less than r. And they need to be able to graph the solution set of the inequality on the number line and describe what it means in its context. So what you should be doing. So let's focus on each piece because there's a lot to this. So let's look on the equation side first. So select word problems for the students that lend themselves to algebraic equations in the form px plus q equals r and p times the quantity x plus q equals r. Some of those are like consecutive integer type problems. You can have the perimeter problem in the standard, things like that that lend themselves to these two-step equations. Facilitate a classroom discussion about the importance of using the order of operations. And provide students problems that can be solved arithmetically but also algebraically, like that perimeter problem in the standard, and facilitate those connections between them. On the inequality side of the standard, again, they need to have them compare those word problems that can be modeled with equations to those with inequalities that are needed to find the solution set, and have them discover those similarities and differences for solving equations and inequalities. That would be a great writing prompt in the classroom, or take it out the door to get to their understanding. Present students with many examples of word problems that can be modeled by and solved with inequalities. Also provide examples of inequalities with negatives so students can discover the need to reverse that direction of the inequality sign when multiplying or dividing by a negative. So again, through context, have them solve and then realize maybe if their solution set doesn't work, and then because they didn't flip the inequality and the need for that. Encourage students to substitute the answer in inequality to see if it makes it true. So again, once they have an answer, making sense, making sure that it is accurate. Have students graph the solution sets of inequalities on the number line and make sense of the solution set in context. So what should students be doing? They should be able to model word problems with equations in the form px plus q equals r and p times the quantity x plus q equals r. They need to solve fluently the equations in those forms and compare algebraic equations with arithmetic solutions of the same problem using precise math vocabulary. So again, problems that they could solve through number sense, and then also have them connect the equation piece. And so I know students might push back a little because some problems they can solve without having to set the equation. But again, push for them to solve using the equation as well, because this is where they're starting to learn and have that the concept and the structure of equations for our more complex equations that are to come in grade 8. They need to recognize if word problems can be modeled by an equation or inequality. So again, I would highly encourage you to have a mixture of problems presented to the students, not just, in this, today we're doing equations, tomorrow we're doing inequalities. Make sure you mix it up some. So they have to make sense of it in the moment, rather than just today's equation day or tomorrow's inequality day. Create and solve inequalities of the form px plus q is greater than r, and px plus q is less than r, using all 4 symbols. That means greater than or equal to, less than or equal to as well. Check answers using substitution. So again, once they have a solution to an equation, they can plug it into an inequality. They can plug in an answer in the solution set to make sure it's still true. And then graph solutions to inequalities with a number line and discuss whether all the answers to the solution make sense in the context of the problem. So again, not only do they have an answer, maybe like x is less than 4, but then does it make sense if you're talking about packages of something to go into the negatives. So some misconceptions. So some students might have difficulty becoming fluent in solving equations. This work started in grade 6 with 1 step, and you're extending it with 2 step. So I would definitely encourage the continuation of a hands-on approach. Most schools have algebra blocks, hands-on equations, algebra tiles, something that we can concretely solve these equations before moving to the abstract. Students may forget to switch the direction of the inequality sign as well when multiplying or dividing by a negative. Again, have students check their answers to the solution set and make sure that the original inequality is satisfied. If it's not, then they need to go back and do their error analysis there. So that's it for this standard. Thanks for watching. If you have any questions, feel free to contact me or your regional specialist. Thank you for making PascoMath more awesome.